Yeah, Rashmita said yes, we can hear it. All right, welcome everybody. So what we're gonna do today is to look at we'll look at we're gonna look at module 13. Now in module 13, we're dealing with data augmentation, more specifically, image augmentation. So the idea is this: in the real world, we have a couple of problems in the real world. Firstly, we don't have thousands of pictures, right? You have to understand that these data sets that you've been using for your projects are what we call curated, right? The idea of curation comes from a museum. In a museum, you have a curator, and that person collects art, which represents certain cultures, certain time periods, certain events, certain people, right? Right? You have this curator. I have a museum curator. And basically what the museum curator does is, like, for example, sort of, you will have museums try to keep it interesting. So what they will do is they will have special events. And so, for example, they'll say, okay, we'll have an event on the life of Amitabh Bachchan, right? Let's say Amitabh Bachchan passes. I mean, eventually he will, right? You'd shake your head like it's impossible. Amitabh Bachchan is what? About 80 years old now. He's not a young guy, right? How old is Amitabh Bachchan? The guy's about 80. It looks great for 80 though. Favorite movie I saw him in was sorry? Yeah. My favorite movie with him was Badla, right? Which I think means revenge. Guy's 82 years old. He's not gonna live forever, right? I keep thinking, how did his son get a wife like Aishwarya, right? But then I realized, huh? Yeah, it's his son, right? Yeah. But the more I look at his son, the more I realize, yeah, it's actually a good looking guy, right? It's not a bad looking guy at all, right? He's a fairly good looking guy, right? Abhishek Bachchan. All right, very cool. So anyway, who is of course, one of my favorite actors. Now, turns out Aishwarya Rai, she was called the most beautiful woman in the world, right? And every time I see pictures of her, I'm like, yeah, right? And probably still is, right? But the thing is that I don't think she's a good actress, right? My favorite actress is actually Kareena Kapoor, right? Now, I have to tell you, the other day I was over in Leading Innovation, and I talked about Kareena Kapoor, and I was getting some dirty looks. And I said, wait, hold on. You here representing her husband? And he was, the person who was giving me dirty looks was saying, yes, I have my eye on it. Anyway, so
you're coming up with different names every week.
Different names every week?
Yeah.
Well, I mean, listen, my best friend in when I was with my PhD, my best friend was a guy called Ajay Kangero from Karnataka, right?
Is he kind of spoiling you?
Spoiling me?
Yeah.
Well, we'd watch Indian movies and all this type of thing. And then he went back to India, but one of my good friends is still he was my best friend, but I wasn't his best friend. His best friend was a guy called Sanjeev Guha from Bombay, right? Who I'm still very good friends with Sanjeev. And we actually do a couple of papers together. Yeah, if you go to Scholar. I've actually done a bunch of papers with his best friend. You see, that's the funny thing about life, though. Many times your best friend, you're not your best friend's best friend. That's life, So many times the person who is your best friend, you're not their best friend. Yeah, so Sanjeev Guha, yeah, I did a bunch of papers with him. Did actually did 4 papers with him, and then I helped him with his thesis. A lot of people think, oh yeah, see, this was my best friend. Yeah. Yeah. See, this is my dissertation. A lot of people think I pretend to like Indians. A lot of people think I've just pretended. Yeah, no. So this guy, Ajay Kangera, yeah. So this is my dissertation, right? So Sanjeev Guha, he helped me, and then Ajay Kangera, Ajay went back to India to manage his uncle's coffee farm over in Karnataka, right? I heard it out. It's kind of a shame. But this is Sanjeev Guha. And basically, I think he mentioned me in his thing because of course I've helped him with the formatting and stuff. Anyway, yeah. So let's say that Amitabh Bachchan passes, right? And so a museum, I might have a special tribute to Amitabh Bachchan, right? I might have works about Amitabh Bachchan, his paintings, sculptures, etc., right? And so this person is a curator, right? So we're jumping from topic to topic here. Anyway, the data sets you've been using are curated, right? So you have these data sets, and they have thousands of pictures per category, right? But this is not real life. That's not real life. In real life, you might have a few hundred, right? Because data collection is extremely expensive, right? And so in real world, you don't have a lot of pictures. Therefore, you need what we call data augmentation. So the idea of data augmentation is that you take the pictures in your training set and you augment them by creating variations of them. You create variations of them, right? And by creating variations of them, it's more likely that you will have a picture in your training set, right? A variation in your training set will probably match a picture in your test set or your validation set. You bother with me? By creating variations of the pictures in your training set, you're more likely to have something that matches your test set, right? Now, right? So, all right. So let's talk about working with an imperfect data set, right? So basically, why do we need data augmentation? Image augmentation, data augmentation, right? It prevents overfitting by enhancing data set variability. Now, we've talked about overfitting, and this is where you train your model on your training set, and it knows your training set extremely well. But it cannot transfer that knowledge to a test set, right? Cannot transfer the knowledge to a test set. Yeah. So imagine you're in Hyderabad. What's it? I should average it. What's the lowest temperature you have in Hyderabad? Which translates to how much Fahrenheit. You know, the thing is, in Jamaica, we use C, but since I've come here, I've been here 17 years, I've been unable to relate to C any longer. Now I think in F, right? It's funny. The first few months when I came here, I was converting prices in the stores from US dollars back to Jamaica to figure out if the thing is expensive or not, right? But you can't really do that because the salaries and everything is different here, right? But anyway, yeah. So I think that's probably about 50s going up to 60s. Yeah, yeah. Good. So imagine you're going to Canada. Yeah. And you decide, okay, I want to know what it's like to Canada. But the temperature in Canada is much colder, right? So imagine that what you do is you lock yourself in a room, in your bedroom, and you turn up the AC up to the max, right? To try to get a feeling for what it would be like in Canada. That's kind of like what image augmentation is, right? What you're doing is varying the conditions that you've been exposed to in the US to more match what it would be like in Canada. So when you go to Canada, you're more prepared. Now I got to tell you, though, when you go to Canada, I went there for a week, and you can never be prepared for that. Yeah, you don't walk in the winter in Canada. You just don't. All right. So it simulates real world variability in lighting, scale, and focus, right? Because in the real world, pictures are lower quality, right? They have defects. They might be blurred, right? Because sorry?
The change of brightness.
Yeah, change of lightness. Lighting.
Yeah, lighting.
Yeah. The lighting varies, right? Some pictures you might take. I mean, uploaded a data set of. So if you look at this data set, for example, of Aishwarya Rai and Kate Blanchett. Kate Blanchett is my actual overall favorite female actress. So yeah, if you look at, so like I said, this is more on personal data set that I was introducing you guys to on Monday. Oh, wait, hold on a second. Yeah, okay, yeah. So I was introducing you guys to my own personal data set. Now I've actually uploaded it to Canvas, and I wish I could show you, but we're having some problems with Duo. But if you go to module 13, if you visit module 13, you'll actually see the data set that I've actually created. I've actually made it available to you, right? Don't know if Duo is working yet. Yeah, still not working. All right, okay, anyway. All right, so that's fine. So yeah, so image augmentation simulates real-world variability in lighting, scale, and focus. It makes models more resilient to edge cases. No, when we talk about edge cases, what do we mean? Edge cases are cases where you have extremes, right? When we talk about an edge case, we're talking about an extreme case, right? So for example, you might have a blurred picture. Yeah. Now, this is very important. It's very important to be able to recognize pictures in all different situations, because here's why. When you deploy this model in the real world, you don't know the image quality you'll be working with. Yeah. You don't know the image quality you'll actually work with when you're actually doing what I call inference, right? Talked about inference, right? So when you train the model on the data, on the training data, you make inferences on the validation. You do predictions on the validation data, right? So in other words, use the model to predict the class of each picture in the model in the validation data set, right? Right? And then in the real world, you make inferences, meaning that when you get a picture that you're required to actually recognize, you want to actually know who is this person. You're running a system in the airport, you need to recognize somebody, right? So we call that inference. I don't know if I've mentioned this before, right? So predictions on the validation set, right? And test set, and inference in the real world. right? When we're actually trying to classify a picture in the real world, we call it inference, right? So when we're doing inference on an edge case, on an extreme case, right? Right? So for example, if you watch these movies, sometimes you see somebody walking, using a hat to kind of partially cover their face. And that makes their face darker. There's less light on their face. Yeah. So if your model is trained on pictures where the person has a lot of light on their face, then your model will not be able to recognize that person's face when they pull the hat down, right? And they're in the shade, so there's less light on their face, right? So by using image augmentation where you have pictures that are darker, then the model is better able to make inferences on that picture when that person's face is darker, right? It's very effective in low data scenarios, meaning few number of pictures. In this training data set, and as a matter of fact, I actually have it up here in the cloud because I knew my laptop started giving trouble on Monday. And so I decided, okay, I'm not going to depend on it. And so, I actually uploaded it to the cloud. So laptop is giving trouble, and now Duo is giving trouble, so I can't get onto Canvas. By the way, people upstairs, people upstairs, please circulate an attendance sheet because I can't get onto the system to do attendance, right? So please go ahead and circulate an attendance sheet. All right, very good. Okay, anyway, so we do transformations. We do what we call transformations. We transform the picture in several ways, right? To augment it, to create a variation of it, right? And by doing that transformation, we're more likely to see those versions of the transformations in the test set, right? So we have partial images, right? Person's face might be hidden, yeah? Might be holding up a hand to their face, might do what Sanjana is doing now, right? I do that a lot. And my sisters always tell me, David, don't do that, right? 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 Might hold up your thing to your face, right? Well, Ice Warrior Ride does that a lot, by the way, somehow, right? Is what I noticed when I was collecting her pictures. Right? So what do? We crop or mask parts. Yeah? We crop the picture or mask parts of it to simulate the partial images, right? Then, of course, you have hidden images, right? You have image sides. And what we do is we flip it horizontally or vertically, right? So if Vijay is looking to the left or looking to the right, I mean, to our human eyes, it's the same, right? It's the same. We flip that automatically. But to our deep learning model, it's a very, very, very different image. Extremely different, right? So what do? We do a horizontal or vertical flip, right? Can be zoomed in or zoomed out. And again, I mean, it's very similar if it's zoomed in or zoomed out. But again, the proportions are different, right? And then, of course, you may have want to apply distortions, right? Where, for example, take for example, when you look at somebody's face through a lens, yeah, convex or concave lens. Everybody remember their physics? The physics teacher told you, these things were going to come back to haunt you if you didn't pay attention in physics, right? So, of course, when you look through a convex lens, let's see, when you look through a anyway, one of them makes your image sort of spread from the center, and one makes it sort of okay, put it this way. When you look at all right, So truck mirrors. So truck mirrors, you have these round truck mirrors, right? And what they're set up in a way so you can see more of the person, more of what's behind you. But it does tend to distort the image. Anyway, you get the idea. You get the general idea, right? Then, of course, you have darkened, brightened images. Darkened or brightened images, right? As Shankar was saying. Low contrast or discolored images. Because again, you know, here's one of the things you realize is that camera technology is always evolving, right? And so here's one of the big challenges of using images of people. What is universal to everybody? What happens to everybody in life? So this is universal. Well, apart from death. While you're living, what happens to you? You do what? What happens while you're living? What changes? What changes for everybody? Age. Yeah, your age. And that's one of the big challenges, by the way, right? That is one of the big challenges, right? So when you look at, if you look at 1,000 pictures of Aishwarya Rai, you're going to find that invariably she's at different ages, right? And so her face looks somewhat different, right? I said that's another challenge of using image data, of especially faces, is that you have these, even if you get a couple of 100 photos, the person is at a different age. What also happens with different photos of people, they have different what in the photo? Different
shades.
Shades. Well, that's the lighting, but their face does what?
Expressions.
Different expressions, right? So they have different expressions, right? And I gotta tell you, Aishwarya Rai is the mistress of expressions, right? She has that almost totally different expression almost every time. She has thousands of expressions, right? If you compare her to Cate Blanchett, I mean, pretty much not a lot of variation with Cate Blanchett. She's usually fairly serious or smiling. And that's kind of it, right? Right? Fairly constant set of expressions, right? Really very bright or just really serious, right? A few expressions. With Aishwarya Rai, on the other hand, it's like an absolutely different expression every single time, right? Totally different expression every time, right? And when she's disgusted, she's not afraid to hide it, right? These are pictures of kind of disgust, right? And almost kind of like, okay, what you're saying here is foolishness. Like, are you serious, right? Here she's kind of laughing at you, right? Here she's like, oh, really? You know, so just all these different expressions, right? And here is like, that's news to me, right? That makes absolutely no sense. But if you say so, let's say that, right? You know, here is, did you really just say that? So the mistress of expressions. So that's one of the other challenges too with faces, right? With faces is that you have these totally different expressions, right? And that changes the shape of the person's face, right? All right, so that's another challenge, right? That's one of the challenges of dealing with people's faces, right? All right, so things like doing the geometric warps and distortions kind of simulate the different facial expressions. Because what happens is that when you apply these transformations, the face looks like it's making a different expression, right? So you have low contrast or discolored images, aberrations and what they call color shifts. And again, you can see this with this data set, right? Where it looks red, pink, brown, greenish, very dark. So just all these different colorations, right? And you know, even with Usain Bolt, like a Usain Bolt, very dark here, very light here, right? Yeah, I mean, you're not gonna mistake him for a white guy, but you know, lots of different color variations, right? In the data set, right? Here it looks super dark. Here it looks more mixed. Yeah. So these are challenges that you're gonna have. Let's look at Vijay, right? Vijay is also kind of a master of expressions. He has a lot of different expressions, right? Whereas Prabhas, right? Prabhas is either usually smiling or kind of serious, right? Kind of like he's kind of like Kate Blanchett. And again, people turn their faces, right? So this is another challenge. And so rotations help with that somewhat. Yeah. So it's very challenging to recognize faces, quite challenging to recognize faces. All right. So yeah, so we have grayscale or unnatural hues, like we said with you know, for example, you know, all these different colorations, right? All these different colorations, and then different exposure, different levels of exposure, right? Etc. Right? All right. Then we have to deal with also blurred or out of focus images, grainy or noisy images. Yeah. And so two things are happening with people's faces as they age. So you have the simultaneous effect. The person is aging, so they're looking different. But also, camera technology is also changing, right? So 20 years ago, you have a picture of Aishwarya Rai. And she's 20 years younger, but also the way the camera took her picture 20 years ago is different, right? So that just even adds to the challenge. So you have age, right? You have camera technology changing, right? You have expressions. You have facial rotation, right? People changing which side of their face you're looking at, right? They're looking at you, or they're giving you the side eye, right? Or they're looking directly dead at you, right? Etc. Right? So all of this just adds to the challenges of recognizing faces, right? So yeah, so facial recognition is really super hard, right? All right. So with the rotation, with the shadow overlays, and background, synthetic lighting to simulate sunlight versus room light, or you know, etc., right? All of these different transformations. All right, here are some libraries for image augmentation, right? You can explore them. And then here's some best practices. Only augment the training data. If you augment the validation data, you're going to get a higher accuracy, because so you only ever augment the training data. Now, one of the things we haven't really talked a lot about either is this thing of imbalanced data sets, right? I mean, we haven't covered every single thing in this course, you know, right? But I should mention that there's an effect of imbalanced data sets, right? So one of the things is that if you have more pictures of Vijay than you have of Prabhas, the model is more likely to predict that the image is Vijay, just because there's more pictures of it, right? So there's also the effect of imbalanced data sets. Now, there's ways to balance the data set, which we won't go into, right? But I just need to mention that imbalanced data sets can affect the model, the quality of your model inferences, right? So when we rebalance the data set to make sure that there's as many pictures of Vijay as there are of Usain Bolt, we do that on the training data, but not the test data, not the validation data, right? Any augmentation that you do, any fixes that you do must be on the training data, right? The validation data must always remain fixed, right? Then you should do what they call domain relevant transformations. So domain relevant transformations, for example, facial recognition is a domain, right? Recognizing buildings is a different domain, right? So one of the things, for example, with buildings is you will have more variation on the lighting. You'll have variation of lighting in pictures as well, in pictures of faces as well, right? But with buildings, you'll have variation of lighting, right? The bigger problem with faces is probably more the rotation of the face. People rotate their face, right? As they talk. Yeah. So that's so if you're taking pictures of, for example, sign language. If somebody's doing sign language, by the way, I think this is a video break. And for a video break, I have to show you this video. If you're doing pictures of sign language, what do you think is a problem you might have with sign language? When you're capturing pictures of people doing sign language, right? This, by the way, this is totally fake, right? Right? 100% fake, right? I might have just told you that Indian movies are the worst movies in the world, right? I might have just told you that, right? I don't know, right? I don't know sign language. I don't even know how to make an A, right? I always wanted to learn, but I didn't. If I'm signing, what do you think is a big problem in capturing those images? Think about it. I'm signing. What am I doing with my hands?
Constantly rotating, constantly.
Rotating constantly. Starts with M. Moving. What happens to moving pictures? Blur, right? So blurring on out of focus would probably be a bigger domain problem, right? I haven't studied this, right? I haven't researched it. But I would think that blurred out of focus images is probably a big problem when you're capturing sign language, right? So in other words, what we're saying is use domain relevant transformations. And the domain is simply the type of image that you're dealing with, right? Facial recognition versus sign language recognition versus building recognition, right? Visualize outputs frequently, right? So in this program I'm going to run for you, you're going to see where we're visualizing the outputs, right? That tells you what transformations are being applied. And it can give you an idea of whether it's simulating the real world pictures, right? Avoid over distorting inputs, right? Because that also creates overfitting, right? And then combine augmentations for realism, meaning do a flip, do a blur, do a rotate, etc., right? All right. So here are some examples. Here's Irish Warrior Rise saying, oh my God, you cannot be for real. I thought you had more sense than this, right? One thing about Irish Warrior, right? She says a lot with her face, right? And she's super, super smart, right? there's an interview with David Letterman where she makes David Letterman regret his life choices. I think that's how young people say it nowadays, right? There's something up. Was it David Letterman or Oprah? I mean, she's been interviewed by the best, right? And um, she was asked something about people living with their parents in India or something like that. And she, she made the interviewer look kind of like, okay, think more carefully the next time you ask a question, right?
There's no need to take an appointment for dinner.
Yes. Great. What's going on with the sound here? Well, there's no sound, but very, very, I mean, this lady should be like an ambassador, right? She's also very strategic. Oh, right. Yeah. Okay. All right. So she turns this around totally on David Letterman, right? Right. And what she does here is she shows that each culture has its different strengths and weaknesses. And what can be perceived as a strength in one culture looks like a weakness in another culture, right? But the thing you have to understand about culture is that culture adapts to suit people, right? Culture is a sort of what I call collective mind, right? It's the behavior of a collective of people, right? And of course, behavior is, shaped to determine survival, right? All right. So anyway, we don't have sound, but all right. So see now, here's the fascinating thing though, right? All right. Parent and child live together. Is it the parent that lives with the child, or is it the child that lives with the parent? See, again, perspective. See? So David Letterman's perspective is that the children live with the parents, right? But in reality, in Indian culture, what happens is that parents are not put in nursing homes. They're kept, and people take care of their parents all the way through, right? So his perspective from an individualistic culture is that you're 18, you move out. You live your own life. Your parents are way less relevant at this point, right? But here, she totally educates him. She totally educates him, right? All right, so anyway. Do you live with your parents? Is that true? So is that we live with our parents because we're dependent on them, or is it that we live with them because we need to take care of them, right? You see, this is whole culture war going on, and she's about to educate them. Totally educates him, right? Totally makes him, right? Has to take a step back, right? We learned a little something here tonight, right? So yeah, the bond with parent and child doesn't disappear just because you're 18 and you're self-sufficient, right? No, we take care of our parents and we make sure they're okay. right? We don't get a call from the nursing home that they fell again and that we need to come and, attend to them, right? Anyway, all right. So here's some code to do all of this good stuff. Sharpness, contrast, blur, brightness, horizontal flip, zoom in, add noise, rotation, etc., etc. And here's some transformations, right? Face only, covered, partial top, monochrome, high contrast, bright or saturated, narrow, wide, faded, noisy, motion blur, low res, horizontal flip, rotated, right? All right, let's run this code. Let's run this code. And as I predicted, my laptop is not cooperating, but that's all right. That's fine. We're gonna try it one more time though. Oh, and I'm actually connected. Actually, I'm connected. I do prefer running things from my laptop. I'm not gonna lie to you. But one of the things is that it's gonna run slower. All right, so let's do this. Let's go over here and reclaim host. All right, so the code is available in module 13, and I'm going to set up a quiz by tonight or tomorrow. Let me go over here and reclaim host. Let's run this. Now, the next module, the final module we're going to look at is reporting, logging, and visualizations, right? In other words, we need to be able to see what we're doing. Is it working, right? So we're going to look at visualizing the features that are learned in the layers, right? And then also, we're going to look at logging and reporting. We need to keep track of our training. Because when you're training these models, typically you're going to run you're going to train the model dozens of times, right? Maybe 100 times, right? You're going to run it with different batch sizes, different number of epochs, not really different number of epochs, right? Because if you use things like callbacks to the early stopping and so on, then you don't need to vary the epochs, right? But different learning rates, different batch sizes, different learning rates, different batch sizes, different transformations, different augmentations, image augmentations, different parameters, hyperparameters, right? Different hyperparameters. And so you want to kind of keep track of it, right? You want to keep track so you can keep track so that you can you can say, you can look at the progress of your training. All right. All right. It's going to give trouble again. So let's go ahead and run it. Let's run it from here. Yeah. Okay. So let's go ahead and run it from here. Okay. So here's our program. And what this program is going to do is it's going to use categorize the eight categories of pictures, right? Guys, nice. Yeah, it's going to do categorize the 8 categories of pictures, right? Right? Of personally curated images, right? And let's see how it does, right? All right, so you have this program. Right? All right, and it's gonna do some administrative stuff. Oh, I know what's going on. I think the hosting is upstairs. I think the host, because I started running, the first window I launched was upstairs. So I think the host, oh, but I'm sharing here. All right. Oh, hello. Okay, very good. All right. Yeah, this is better. It's gonna work out better. All right, so let's do some sharing down here. All right. Stop sharing. Let's stop the share here. Right. Let's see if we can share it from the laptop. All right. So now I am screen sharing here. Oh, okay, move this. Okay, all right, here we go. Okay. What we're gonna do is turn off this video because this video is not helping. I don't think this video is helping. All right, very good. Okay. All right. So let's run our program. Okay, so the first thing we're gonna do is, so the first thing I should show you is actually this image pre-processing. This image pre-process program, right? Now I'm not gonna actually run the program, but the first Can you guys upstairs hear me now? Yeah, because we were using the audio on this fast computer and then the video and then the Zoom that. Okay. You guys upstairs, can you hear me? You can? Okay, all right, good. All right, perfect. All right, thanks. Yeah, so the other thing with real world pictures is that you have a lot more than a face, yeah? And so you have to process it to crop it down to the face. I mean, I mostly capture just the face here, right? But, typically you have here, you have shoulders, you have neck, all of this type of stuff, which you're not interested in, right? You're not really interested in all of this. So the other thing with real world pictures is that there's different resolutions, yeah? They have different resolutions. So this one is, so this one is 568 by 635. This one is 171 by 184, right? This one is huge. This one is huge, right? So you have different pictures have different resolutions, right? And so we have a couple of problems with real world pictures. First, different resolutions. Then we have parts of the image that we're not interested in. Here, neck, shoulders, clothing. We're not interested in that, right? What was the other thing we said? Okay, so we need to do some pre-processing. I'm not going to run the pre-processing, right? I'm simply going to show you what the images look like after being pre-processed. So after pre-processing, then we end up with, so guys, you're literally throwing me off. After pre-processing, so we have the pictures that all have the same size and they're only showing the face, right? Right? So they're all the same resolution. All the same resolution. Still different sizes, but all the same resolution and only showing the face. So this is kind of what the image pre-processing looks like, right? You said the output directory, image size, etc., right? And so of course the image size is the resolution, the pixels by pixels, yeah? Does some pre-processing and creates the images ready for training. Okay, so let's look at our actual program to train our models, right? Okay, so we set up our training directory validation directory, our batch size. Remember with batch size, the bigger the batch size is, the more you learn per epoch, right? But the slower the learning per epoch, right? It also stabilizes the training. When I set the image picture target size, the picture target size is going to be used by our data or image augmentation and data loader, right? Now, here are some image augmentation presets that you can play with, yeah? So we have in all 5 image augmentations, right? What we do is we have a kind of basic image augmentation, yeah? So whether we center the photo, normalize the photo, the whitening, rotation, width shift, height shift, shear range. Shear is when you twist the photo, right? You enlarge one size and you reduce one size. Vertical flip, horizontal flip, right? Brightness, all of this type of stuff, right? And then we have some different augmentations that you can actually play with. So what I want you guys to do is to actually download the program, download the data, and play with it. Now, like I mentioned, what I want is I want to write a paper or possibly 2 papers. Now, people, this is very, very important. You're going to have to set yourselves apart from other credits. You're going to have to go above and beyond to distinguish yourself. It's not going to be good enough to say you did deep learning. So how do we prove that we have deep learning skills? What's one thing we can do to prove to an employer that we know deep learning? Or something we can do?
Doing a project.
Doing a project. Yeah. Do a project. Now, doing projects, that's great. How do you show that they're good projects? Well, if we get it published or get it into a conference, an employer could be impressed. So over the summer, I'm going to be working on this concept. Like I mentioned it on Monday. The concept is, and so for example, we could do 2 or 3 projects over the summer with 2 or 3 groups of students, right? And we could do a project on, for example, does the model recognize men better than women? Does it recognize people of a different race better than people of the same race? Does it recognize Chinese people better than white people, right? We can have all these different variations on image recognition, right? In deep